In this video, we're going to look at part 2 of the real estate case assignment, and we'll do examples of the different types of statistical tests that are used. In addition, we'll also talk about some of the important results or findings that we could draw based on our test results. So here is a screenshot of the case report template, and we're looking at the research objective 3. So let's read a little bit. Sample statistics were tested against population benchmarks for this real estate market. Now these benchmarks are assumed values for either a population mean or a population proportion, depending upon whether this is a quantitative variable or a categorical variable. So those assumed values are given in our case instructions. So let's have a quick look at those. So there are two main sections to this part of the real estate case. The first is checking the sample information. Frequently, we might compare our sample information to some population benchmark to determine if our sample is a good sample. That is, does it represent the population pretty well? Now, this works really well with something like characteristics of a home, because in a particular neighborhood, the square feet average wouldn't change a lot over time, nor would bedrooms or bathrooms, or the different types or ages of homes. Certainly age can vary as the homes get older. Same price can vary. Okay, so what we're saying right here is that right now the average price is $350. Let's see if our sample is pretty close to that. The average square feet, 2,300. Bedrooms, bathrooms, you could see that, and 50% each, contemporary homes and homes that are in the young category. So now all of these benchmarks can be tested using our sample information and either the one sample t-test for a population mean or a one sample z for proportion. Let's look at that. Now we're also making some assumptions about proportions. We are interested, the case instructions explain, that we're interested in this neighborhood because it is believed to have at least 50%, the assumed value of 50% contemporary style homes. Now this can't be a one sample t-test for the mean because type is categorical. However, we still only have one single variable, so this is a one sample test, but it's a one sample z-test for proportion. So variable number 5, our type, and we're specifically looking at that contemporary, or it's abbreviated contemp category. So we're looking to see if there's about 50%. Our sample only shows a sample proportion of 44.6%. It's about 45%, a little bit less. But we can see that our sample does not differ significantly from that 50% assumed proportion of contemporaries. Again, the p-value is very high, and the test value of 50% is clearly within the confidence range. If we wanted to test the quality of our sample information in terms of square feet, we could use our one sample t-test, and we could test that assumed value of 2,300. So square feet is variable 2. We could run this test very simply using our inference for means tool. And specifically, this would be a one sample t. Now, why is this a one sample t-test for the mean? Well, it's a test for the mean because our data are quantitative, and we're making inference about only a single population mean, mu equals 2300. And for this reason, we're choosing the technique, the one sample t. So we could see here that the p-value is quite high at 0.27, and that is not at all a statistically significant result. Further, we could see that 2,300 square feet, that assumed mean, is within our range of estimate. Our confidence range includes 2,300 pretty clearly. So what can we conclude here? Well, we can conclude that our sample does not differ significantly from that 2,300. In this case, we might simply say that our sample is pretty good in terms of the square feet. The next section of this part of the real estate case considers the effects of these home characteristics on price. Now, as you know, this has been a pretty important consideration even in part one, where we were using the mean differences among types or the mean differences among age categories. And we were also looking at proportion differences using the same independent variables, type and age category. But of course, to cross-tabulate, we were using prices in categories. In part one, we could only look in the sample data to see any differences in means or differences in proportions. But in this section of our casework, we're going to use statistical testing to see if we can determine whether the differences that we see, or these effects, are statistically significant. Because if they are, I could assume that effect will hold throughout the entire real estate market. So the results of our tests are very important to our application of our analysis more broadly. So this next section is going to require that we use three tests. One is the two sample t, one is the ANOVA, and then on our proportion tool, we'll look at a test that's called the chi-square test of independence. So these are new, but let's connect them to what we've already done. The two sample t is going to allow us to take a quantitative variable like price and group it into two separate samples. So this would be appropriate if our independent variable is in two categories, and only if our independent variable is in two categories. So we did this analysis in part one. We grouped the prices into two samples, old and young. Okay, or we could put these in any order that we want. We could say young and old. We're making two samples and we're comparing the means. The only step that we're adding is a p-value test to determine whether the difference is significant. On our t-test results, we can see our two sample means, and the observed difference of 307.86 is calculated for us. The two sample t just compares this observed mean difference to an assumed value of 0 difference. The t statistic and the p-value give an indication of how strong this result is. T for 72 degrees of freedom is 3.57, and p equals 0.0006, which is a highly significant result. So we're concluding here that age category has a highly significant effect on price. On average, the young homes will be 136 $479.066 to $479.646 greater in price than the old category homes. Now, the 2 sample t was appropriate for the independent variable age category because there are only 2 categories, 2 sample t. We're comparing 2 means, or we could say we're making inference about 2 population means, the difference between them. ANOVA is a technique that we could use when we're comparing more than 2. In our class, we're only comparing 3. So the way we would determine which to use, if our independent variable is in 2 categories and we're comparing means, so our dependent variable is quantitative, 2 sample t would be the correct test. If our independent variable is in 3 categories and we're still grouping those quantitative prices, now we need to use an ANOVA. For example, type has 3 categories. The ANOVA is going to do conceptually the same thing as the 2 sample t. In fact, conceptually, you can think of this as a 3 sample t. We're just comparing 3 means. Mathematically, it's run very, very differently, and we'll talk about some of those details more in class. But now we'd like to provide an overview of how we can use this test to complete our case. A p-value test like any other, ANOVA allows us to see at a glance whether or not this effect is statistically significant. What we're considering is whether the difference in the sample means pools, considering everything else like variability, whether that difference pools to enough difference that we would call it statistically significant, or in other words, unlikely to occur at random. Our p-value of 0 tells us this much mean difference is not an accident of luck. This is a true effect. The type of the home is associated with the price of the home. So when using 2 sample t or ANOVA, our independent variable is always in categories. It's okay if it starts out as a quantitative variable, and then I would need to group it into categories, like we've done with age. And we're adding, for this part of the case, the same type of grouped variable. Square feet has been grouped into categories, bedrooms and baths as well. So if our independent variable is in categories and our dependent variable is quantitative, the correct test is either 2 sample t, 2 categories, or ANOVA, 3 categories. Well, if we want to look at this a little bit differently with our independent and dependent variable in categories, of course, we already learned in part 1, this is a crosstab situation. So let's look at something like age category. This is one that you did for part 1. And our dependent variable here would be price category. Low, mid, and high. So the crosstab, and specifically the conditional distribution by age category, shows us the effect that age category has on the proportion of each spending category. In other words, if we see differences here, being in the young category seems to have an effect on the percentage of high-price homes. In simpler terms, younger homes seem to cost more. These differences are notable in the high and low categories in particular. But now we would like to add some way of determining whether this is a statistically significant effect. In other words, when we say that, and we're saying that a lot, when we say that, we're saying that what we see in the sample data can look like a strong effect, but maybe it's just occurring randomly in this one random sample. When we set up a formal test to produce a p-value, that p-value is going to tell us the probability of getting this much effect at random. When that probability is very low, we say, well, wait a minute. Then what we're seeing in the sample data is no accident of luck. It's indicative rather of a true effect. For example, our chi-square test of independence is the test that we run with crosstabs. And a p-value, like any other p-value, here we can compare to alpha. P-value of 0.0021 is quite a bit less than 5%. In fact, it's less than 1%. So we could conclude here very strongly that the age category has a highly significant effect on the percentage of spending category. You're much more likely to be in the high category if the home is a young home. So looking again at our case report template, you can see that that first part, running our one sample t-test or one sample z-test, can be reported in Table 7. We would have a test for each of those variables listed: our price, our square feet, bedrooms, bathrooms, and so forth. And we're comparing our sample data to those benchmarks, reporting our test value, which is the benchmark given, and then the p-value that we obtained from our test. So what we're trying to show here is that our sample compares pretty favorably to those benchmarks. In the second part, this is just an example because the way we report these results can vary, but essentially what we're doing is we're trying to show the effects of these independent variables. For example, I used a 2-sample t here, and I got a very strong result, and we'll talk more about how to report those specific results. I also used that same age category variable to run a chi-square test, and again we got a very strong result. So in the second part of our real estate case, our goal here is to run several of these tests to try to get an overall sense of the significance of these effects from the characteristics of our home on to the price. Now, this gives just an overview of each of the tests, but what we'll have to talk about a little bit more as we do more examples in class is what we call post hoc analysis, and then of course we've already started talking about the assumptions of each test. So post hoc analysis helps us really get to the specifics of our results. And of course the assumptions, we need to at least address those insofar as we say that they've been checked and considered and hopefully 100% met. So some more of those details we'll discuss in class, but this gives you hopefully a general overview of the tests that we're running to complete part 2 and how we're running those tests.